Quick question. Have you ever written a for each loop in C# and not thought about what's happening underneath? Like, you're looping over a list, a dictionary, or maybe even a custom collection and it just works. Today we are pulling back the curtain because the innocent for each is powered by a design pattern senior devs use all the time, whether they realize it or not. Today we are talking about the iterator pattern, and by the end of this video, for each will never look the same again. By the end of this video, you'll know what the iterator pattern actually is in plain English, why it exists and what problem does it solve, how C# already uses it everywhere, and how you can implement it cleanly in your code like a senior dev. No theory overload, just concepts that stick. This video is part of my series Design Patterns Code Like a Senior Dev, where we take patterns that usually sound scary and turn them into something you'll actually use at work. If you are a junior or an intermediate dev trying to level up, this series is made for you. Let's start with a very real problem. Imagine you are building an app that manages a playlist. Inside your app, the songs might be stored as a list, as array, as queue, or if you're feeling adventurous, maybe linked list, or something custom that you built yourself. Now, here's the catch. You want users to loop through the songs, but you don't want the rest of your app care how those songs are stored. So without a proper approach, your code starts looking like this. Oh, if it's a list, loop this way. If it's an array, loop another way. And if it's something else, good luck. That's messy and it's not very maintainable, to be honest. This is exactly the problem that iterator pattern solves. The idea is simple. Provide a way to access the elements of collection sequentially without exposing its internal structure. In human terms, let me loop over your stuff. I don't care about how you store it. Think about a TV remote. When you press next channel, you don't know how the channels are stored or whether it's cable, satellite, or streaming. No. You just press next and it works. That's the iterator pattern. Now, here's the cool part. You have already been using the iterator pattern in C# probably every single day without even realizing. Anytime you write a for each statement, you're using an iterator pattern, because behind the scenes, for each works with IEnumerable, which exposes an IEnumerator, which controls how the iteration happens. And that's not an accident. That's the design pattern which is implemented by C# underneath. Now, let's build one ourselves, step by step. Before we write a single line of code, let's be clear about the goal. I want a playlist object where songs are stored internally. The internal structure is hidden, but I can still use for each on it. If I can do that, I have successfully implemented the iterator pattern. So let's start simple. I'll create a playlist class that contains a list of songs. So now we have class called playlist and we have a song that is a list of string. Notice the word private. This is important because I don't want other parts of my code messing with my data directly. So now I need to add a way to add songs to it. So what I will do now is I will add this method called add songs, which will just take the song in and add to the collection or add to the list underscore songs. Right now, the only thing that the outside world can do is add songs. They cannot remove, reorder, or even know what's the underlying data structure that is giving them songs. That's good encapsulation. Now, we don't want to directly expose the list. We only want to expose the ability to loop. That's the key mindset shift of iterator pattern. So now what we would do is we would implement IEnumerable of string right here, and when we implement this interface, it would force us to implement two methods. One is getEnumerator and another one also is getEnumerator, but the difference between these two is the one is generic IEnumerator of string, which matches with this one, and then another one is plain old IEnumerator that is non-generic. Alright, this line is talking to the C# compiler, where we are saying, hey C#, this object can be iterated. That's it, nothing more. We are not saying how, we are not exposing storage, we are just making a promise that this object can be iterated. So now we would tell the compiler how we can iterate over this object, which is simple. So this getEnumerator is the object that would tell the caller how to iterate over it. So what we would do is, because songs already, or the list rather, already has a way to iterate over it, so we would just pipeline that iteration over to songs collection. So we need not to implement this ourselves, but we are just delegating whatever the work enumerator does to the enumerator that we already have in this list. This is called delegation and developers love it, right? And now comes the payoff. We can loop over the playlist directly because we have these enumerators exposed. So I'll just create a new playlist object and I'll add a bunch of songs to it. After doing that, I'll just iterate over all the songs in the playlist. And yeah, that's pretty much it. So now if you see, we can loop over the playlist directly, or rather we can loop over all the songs that are present in the playlist directly. And no one really knows how the songs are stored inside the playlist, whether it's a list, array, or something else. And that's exactly what we wanted. Let's try and run this. There we go. We have successfully iterated over the songs that were in the playlist. This is why senior developers love Iterator Pattern. Your collection can change internally. You have all the liberty to change the implementation of it. Or let's say if you were using arrays before, you can turn it into a list, or maybe a dictionary, or maybe something else. Second point is your iteration logic stays the same. Any code that is dependent upon iterating that collection, for them it just remains the same. Now, your code is cleaner, safer, and easier to extend because of this fact. So let's recap what we learned today. We learned what the iterator pattern actually is, the problem it solves, and how foreach uses it under the hood. How to implement yourself in C#. You didn't just learn what it is, you learned why it exists. This is just one pattern from my series Design Pattern Code Like a Senior Dev. So if you want to write cleaner, smarter, more professional C#, check out the rest of the videos in the series. If this video helped you, hit like, subscribe, and do all those things. And I'll see you in the next pattern. Until then, code clean and think like a senior dev.